My name is Jay Lister.
I'm Justice Lewis. Alexis Kelly.
Montavia Williams.
Correll Bradford.
And we're doing rocks and minerals.
Mineral.
Chapter 17.
So a mineral is defined as a naturally occurring inorganic solid element or compound with a crystalline structure. A mineral could be something in your body such as vitamins. It could be something for a plant fertilizer such as nitrogen, or it could be just a rock taken from the earth by a human. Crystal structures. The crystal structure of a mineral can be made of atoms of all kinds of elements. So you have a diamond, which is made from carbon atoms, and then you have a quartz, which is made of silicon and oxygen. These are two different structures, but no matter how many atoms each element has, or each mineral has, they all have their own defined chemical composites. Silicates and non-silicates. Silicates contain up to 90% of the Earth's crust. It's basically made of silicon and oxygen. So non-silicates have no silicon, oxygen, tetrahedrons in crystalline structure. They make up the rest of the 8% of the Earth's crust, and they have 8 groups. So the groups are carbonates, sulfates, oxides, sulfides, halides, phosphates, hydroxides, native elements. The silicates have 4 main arrangements that they go by, which are the sheet silicates, the framework silicates, chain silicates, and the isolated tetrahedrons. The physical properties of minerals is the color, the streak, and the hardness. The color really isn't useful, but the streak, it can tell you what kind of mineral it is, and then the hardness, it goes to where it resists the scratching. So pretty much the streak and the hardness will tell you if it's a mineral or not.
Alright, so I had mineral forming process. And so basically this is how most rocks and things are formed. They go through a process. So minerals, crystals, usually form through solids and liquids environment, but they can also be formed through gas and solids under the right conditions, so that means under the right pressure. There are 4 major processes in this, and it's the crystallization from the magma or lava, the precipitation, the changes in the pressure and the temperature, and rocks can also be igneous rocks, materials, and molten rocks. Mineral forming process is also influenced by the temperature, process, time, the ability, and the concentration. The 2 liquids environment are made of water solutions and a solution of hot, and that includes molten mass, melted rock known as magma, and most people call it lava. And in the right corner you can see a picture of the lava. It's very hot, so once the lava touches the rocks and anything like that, that's when the process starts changing. And magma is forced out of the surface, so that's called lava. And minerals also can be formed in the intense heat and pressure found far below the Earth's crust mantle.
Rock is a formation of one or more minerals and perhaps other materials that have been brought together in a cohesive solid. So most rocks are composed of silicate materials, and silicate materials are made of silicon and oxygen. Minerals are physically combined to make rocks. There are 3 types of rocks: igneous, sedimentary, and metamorphic. The first rock is igneous, which is formed from magma. And most rocks start out as igneous rocks. There are 2 types of igneous rocks: extrusive and intrusive. Extrusive forms above the Earth's below the Earth's surface and extrusive forms above the Earth's surface. The second rock is sedimentary rock, which is formed from particles and dissolved minerals from pre-existing rocks. In sedimentary, you have a process called lithification, and that's the rock forming process. In lithification, there are two types of rock forming processes. There's compaction and cementation. Cementation is where a material gets stuck into the rocks, sticking them together like glue. And compaction is basically where the rocks are pressed together with some type of force. And the third type of rock is metamorphic, which is pre-existing rocks that are changed by some type of element like heat or pressure or anything like that. So it's a rock that's changed to make another type of rock.
After a chemical analysis of the surrounding area known as the Earth's crust, we found that there's evidence that during the molten stage of the Earth's development, that heavier elements such as iron and nickel sank to the interior parts of the Earth, and lighter elements were left on the top of the Earth, which we know as the crust. There are 8 prime elements that make up the Earth. 98%, right? So just to give you a little bit of a breakdown, 50% of the Earth's crust is made up of oxygen, about 25 is silicone, and that together is 75%. And then after you factor in the other elements such as magnesium, aluminum, iron, just off the top of my head, that equals 98.6% of the Earth, and the remaining other elements is 1.4. The Earth's crust, minerals and rocks are also considered solid materials of the Earth, and there's about 25,000 minerals on the Earth, but there's only 20 common known minerals, and those are quartz, fluoride, and mica.
I will be talking to you all about the rock cycle. The rock cycle is a process of underground rocks and Earth's crust. The rock cycle is a model that describes formation, reformation, and breakdown of rocks such as metamorphic, igneous rocks, and sedimentary rocks. They're all made up of minerals. Any particular rock sample today has gone through countless transformations in 4.6 billion years and will continue in the future. The rock cycle has many different pathways such as melting, pressure, and erosion. The rock cycle is a group of changes like igneous rock. It can change into sedimentary or metamorphic rock. Sedimentary rock can change into metamorphic or igneous rock, and metamorphic rock can turn into igneous or sedimentary rock. The rock cycle begins with molten rock magma below ground and lava above ground, which cools and hardens to forms of igneous rock. Exposure to weathering and erosional forces break the original rock into smaller pieces. The smaller material now is called sediment. It's carried away by rivers, winds, glaciers, and other means, and is eventually deposited elsewhere.